All right, let's take a look at this example here. So a 128 Newton carton is pulled up a frictionless baggage ramp inclined at 30 degrees above the horizontal by a rope exerting a 72 Newton pull on the ramp surface, parallel to the ramp surface, If the carton travels 5.2 meters along the surface of the ramp, calculate the work done by the rope, gravity, normal force, and what is the net work done? All right, so here is my picture. My force is being pulled parallel to that incline. Normal force always points perpendicular to the surface, and here is mg. And it wants me to find the work done by each one of these forces and then find the net work, the total if I add them all up. So first thing I need to keep in mind is when I'm finding work, all of these forces are constant, so I'm going to be using the work is equal to force parallel times displacement. So I need to make sure that the force I'm using is parallel to the displacement. If it's not parallel, if it's at an angle, I have to resolve it into components and find the parallel component. If it's perpendicular, no work is done. So the first one is this 72 newtons. Now I notice these 72 newtons is right parallel to that 5.2 meters, so that's nice. So the work is going to be 72 and it's in the positive direction, plus times the positive 5.2 meters. So I went ahead and I've kind of rotated my coordinate system so that the positive direction is up the incline in this case. For B, I want to know how much work is done by gravity. Okay, so I see that gravity is not parallel with the 5.2 meters. So I need to resolve it into components. So there'll be a component of gravity that pushes it into the plane, and there's a component that's pushing it down the plane. So this angle here is also that theta, that 30 degrees down here. So I have mg cosine of theta there, mg sine of theta here. And I want to find the work done by gravity. So I have to find the work done by each of those components. Well, this component is perpendicular to the displacement, so no work is done by mg cosine theta. However, mg sine theta does do work because it is parallel with that 5.2 meters. But you'll notice mg sine theta is pointing in my negative direction. So the work done by gravity here is going to be negative mg sine theta, which is going to be 128 times the sine of 30. So that is the force of gravity kind of pushing down that incline times my 5.2. And when I plug these numbers in, what do I get here? I end up with 374.4 joules for the first one and negative 332.8 joules for the second one. All right. And then C wants to know how much work is done by the normal force. Well, perpendicular to the displacement, so the normal force does no work. So the work done by the normal force is 0 joules because the normal force is perpendicular to the displacement. To find the total work, I just need to add these three works up, and I get a total of positive, so this is the net work, positive 41.6 joules. And what does that positive tell me? That positive tells me I'm overall adding energy to my system. So I'm adding kinetic energy, meaning it's speeding up. All right, so there is our example.